Module 5 is about hybrid wireless network. It is actually a combination of uh, cellular network as well as ad hoc network. So in that case, the initial lecture was about the introduction of hybrid wireless network. And then yesterday, what we had seen was what are the three main architectures of hybrid wireless networks. So they were MCN, HWN, and Soprano. And after that, one half an hour session was taken, conducted, which is called as a special session. That was about open issues in next generation hybrid architecture. So there I had discussed about 6 points and a few more points I had shown. So there's open issues in next generation hybrid architecture can be asked for a 10 marks question. If it is asked, you should be able to write at least 8 to 10 points and explain it. So with those introduction about hybrid wireless networks, which is also called as HWN, let us see what are the different other criterias. So other criterias, as you can see here, today we are going to discuss the routing in hybrid wireless network, because I told you initially that hybrid network is a combination of cellular network, which is infrastructure based, and ad hoc network, which is infrastructure less. So we will see that the routing which we had used in case of infrastructure based cellular network or infrastructure less ad hoc network cannot be directly implemented in case of a hybrid wireless network. Okay. So for hybrid wireless network, a special feature of routing protocol is to be determined. All those things we will see today. And then this power related issue is always there in case of all layers. In case of the first chapter MAC protocol, we had seen what is the power related issues. Then in case of routing, in case of QoS, everywhere the power related issue was there, because ad hoc network is heavily power constrained. So saving energy or power at every step is our main concern. So in case of hybrid wireless network also, there are mainly two power control schemes. We will see that today. Load balancing is a very important issue. So what is meant by load balancing? We should see that a specific set of nodes or a specific set of path and nodes are being overused. If they are overused in case of a ad hoc network, then what happens is that set of node or that path becomes exhausted, and power in those nodes are always used, and power in those nodes are all gone. Okay, so if some nodes and some paths are overused, in that case the battery in that nodes actually are discharged very fast. So in that case, those node becomes dead, and that path become a dead path. So no power transmission can happen through that path. So load balancing is a technique which ensures that one path or two paths, they might be very small path, they have a small distance path, they might be very optimized path. Okay, but we should not use same path over and over again. In that case, all the battery in that path node will be discharged, and that path will become a dead path. So load balancing is a technique by which the transmission load, that is the packet to be transferred, are shared over many paths, okay, between the source to destination. So if there are 4 or 5 different paths, we have to ensure that all the packets, so if there are 100 packets, we should not use only one single path to transmit all those 100 packets. So if there are 5 paths between source and receiver, it's a multicast kind of a network. In that case, we have to see that in that case we have to see that each path, so 5 paths are there between source to destination, each path is carrying 20 packets each. So that is actually the load balancing. So why load balancing is required in hybrid wireless network, that thing we will see. So first two topics full, that is routing and power control, and load balancing in introduction. So this will be our topic of discussion today. So what are the routing issues in hybrid wireless network? There is only a one slide explanation. Why do we require a special kind of routing in hybrid wireless network? So there are mainly 4 points we will see. And now onwards, whatever discussion will happen, you will find we have discussed the same points in case of previous ad hoc networks. So the discussion is understood, It will be understood by you, but only you have to remember all these points. So this actually routing issues in hybrid wireless network. It says that routing protocols available for cellular network and ad hoc network, they fail to provide good output in case of hybrid wireless networks. Reasons are following. So these are the reasons, four reasons for which direct routing protocol of cellular and ad hoc network cannot be directly applied in case of the hybrid wireless network. So what are the reasons? First is in hybrid wireless network HWN, the base stations are present. Okay, in cellular also base stations are present. In ad hoc network there is no base station, but in hybrid network base stations are present. Okay, so I told you initially hybrid network is actually a combination of cellular network and ad hoc network. So some features of cellular will be there. So base station is a feature of cellular network. It is there in hybrid network. So what problem base station is creating in hybrid network? Let us see. So hybrid wireless networks have extremely reliable and fixed base station because base stations is controlling all the communication between all the MH, that is the mobile hosts, which are nothing but the sensor nodes who are acting as a source, router or destination. So hybrid wireless network has extremely reliable and fixed base station with mobile nodes. Existing ad hoc routing protocol don't exploit the base stations or fixed infrastructure. So if we are thinking of ad hoc routing protocols, in ad hoc routing protocol, there is no mention of base station because ad hoc networks are not using base stations. So the protocols which are written for ad hoc networks, the protocol which are decided, the algorithm which are used in ad hoc network, they can never be used directly in hybrid wireless network because ad hoc protocols are not counting the base station into it, and hybrid network are always having base station in it. This is the main reason why the routing protocols of ad hoc directly cannot be applied for hybrid wireless network. Yes, the protocol of cellular networks may be applied to hybrid wireless network, but not directly because cellular network is totally controlled by the base station, but ad hoc networks are not controlled by base station. And in hybrid network, there is a part of ad hoc network as well. Okay, so this is the main problem, that is base stations are there in hybrid wireless network and ad hoc protocols, routing protocols are not using the base station into its algorithm. Hence the protocols of ad hoc routing cannot be used for hybrid wireless network. Presence of high speed wired backbone. So yesterday's lecture we had seen in case of soprano, that is if there are two cells side by side, as you see in case of mobile communication, that is mobile phone communication. So if there are two cells side by side, at the center of the first cell there is base station 1, at the center of second cell there is base station 2. So base station 1 and base station 2, they are having a specific link, that is a high speed data link between them, but the base station with the other intermediate nodes, they are not the high speed network. So there are two types of communication go on within a cell. One is between two base stations, so there is a very high speed communication, but from base station to the other intermediate nodes, that is a kind of a low speed communication. So let us see what is the presence of high speed wired backbone is the problem, what problem is that creating in case of HWN. So it is saying that presence of the wired network connecting the base stations has to be considered in the design of the routing protocol. Communication among base station is at high speeds and at low cost. Okay. So if you are using a wired protocol, so wired protocol is cannot be directly applied in case of HWN, that is the hybrid wireless network, because wired protocols are using very high speed communication lines. Okay, but in this case, whenever you are talking about hybrid wireless network, there are they are not that high speed communication lines. So that is what I said, presence of wired network connecting the base stations has to be considered the design of routing protocol. Communication among base station is at high speed and at low cost. This holds for exchange of routing information also, but routing information exchange is a slow process. So whenever I'm talking about ad hoc network, in that case routing and all those informations are exchanged in a very slow manner. Okay. But if it is a wired connectivity, in that case the routing information exchanged between some intermediate node and base station is a very fast process. So ad hoc routing is slow, but wired routing is fast. And this hybrid network is having both. A hybrid network is having ad hoc as well as cellular. So cellular routing may be fast, but ad hoc routing is slow. So whenever I'm talking about hybrid, it is having both the things, ad hoc as well as cellular. So typically only one type of routing protocol, if you are trying to implement over HWN, it is not possible. So only a cellular routing protocol or only ad hoc routing protocol directly, if you are trying to implement on hybrid wireless network, that will not be useful. Okay, that means there will be a speed mismatch. Okay, directly if you are trying to apply cellular or ad hoc protocol routing protocol on hybrid, there will be a speed mismatch. Okay, so we have to write a special code, we have to design a special algorithm, and we have to write a special kind of routing protocol for hybrid wireless network. That is what it is saying. High routing overhead. Okay, so in ad hoc network we find that ad hoc network is not having any base station. All the intermediate nodes, they act as the distributed kind of a nature, they're distributed kind of a nature, and all nodes together, they actually helps to do the routing thing. And in the routing process, a lot of control overhead, that is RTS, CTS, DS, acknowledge, all those packets are exchanged. Okay, so those packets are actually adding to the uh, control overhead in case of ad hoc network, and that is a problem. And hybrid wireless network does not want that much control overhead. That is a problem. So high routing overhead in ad hoc network is a problem. Hence, directly routing protocol of ad hoc you cannot apply for hybrid wireless network. Let's see what it says. The fully distributed nature and highly dynamic topology in ad hoc wireless network results in significant routing overhead, because whenever we are trying to establish a path, before the path establishment we have to exchange RTS, CTS, then there will be acknowledgement, then there will be DS if it is macro protocol and all. So all this RTS, CTS, acknowledgement, DS, all these things are overhead. So it is saying that the fully distributed nature and highly dynamic topology. Fully distributed nature means there is no centralized control, there is no base station in case of ad hoc network. Hence, all the nodes together, they do kind of a distributive management of the routing protocol. So the distributed nature and highly dynamic topology of ad hoc wireless network results in very large amount of routing overhead. This affects the network output. So if the overhead is more, in that case it will eat a lot of power, it will eat a lot of bandwidth, and that will harm or that will reduce the overall output of the network. Because to establish the connection, a lot of time goes to establish the connection, we are losing a lot of bandwidth and power, because to establish those links we have to exchange a lot of control overhead, control packets. Okay, so that is what is saying. This affects the network throughput, that is the routing overhead. Hence, routing protocol designed for ad hoc wireless network are not suitable directly in hybrid wireless network, where output enhancement is of primary objective. So hybrid wireless network is designed just to have maximum amount of output, and output will be maximized if the control overhead is less. Hence, it is saying that as ad hoc wireless network is having too much of control overhead, if that routing protocol is directly applied on hybrid wireless network, the hybrid wireless network output will be reduced. Okay, but it is not done, because the main objective of hybrid wireless network is output enhancement or throughput enhancement. Routing in hybrid wireless network may use base stations, such as the routing overhead can be significantly reduced. So if we are using base station instead of the distributive kind of routing, in that case base station will take care of all the routing part. So base station will establish the contact between the sender and receiver. Base station will act as a relay between the transmitter and the receiver. Hence, the control overhead will reduce. So problems are also discussed in every point, and solution is also discussed in every point. So you have to understand that. So high routing overhead of ad hoc is the problem. Solution is base station if you are using. Okay, so if it is hybrid network, we can use distributed kind of routing, we can use centralized kind of routing. For centralized kind of routing, we need a base station at the center of the whole topology. Last point is scalability. So scalability means for a smaller network, we can design all the routing and other thing. Smaller network means maybe some 5-10 sensor nodes are there. But if we want to establish the same protocol, if when the network is scaled up, what is meant by scalability? Initially, we test the routing protocol for 5 or 10 sensor nodes. That is for smaller number of sensor nodes. Then we are finding that yes, the protocol is working fine. Then what we do is let us scale the network up and apply the same protocol whether the protocol runs there or not. So scaling up means increasing the number of nodes. Initially the protocol was used for 5 or 10 sensor nodes. Protocol was working fine. Now let us scale up the network. So maybe for 100 nodes, let us see whether the same protocol runs or not. Okay, so that is the scalability is the issue. So maybe in case of small number of nodes, the protocol will work fine. But as soon as the number of node increases, the protocol might not work. Okay, because there might come some intermediate issues in that case. So the current routing protocols, that means ad hoc routing protocol and cellular routing protocol for, so current routing protocol for ad hoc wireless networks have high routing overhead, hence their performance degrades when used in large network. Now just see, this is the problem of scalability. If there are 10 sensor nodes and you are applying a routing protocol, in that case, that routing protocol might work. Because if there are 10 sensor nodes, whatever overhead is produced, that is somehow manageable. Okay, so for 10 sensor nodes, the ad hoc routing protocol might work, okay, properly. But if you are trying to do the same thing with 100 sensor nodes, possibly the overhead will increase in a nonlinear fashion. Okay, it is not that for 10 networks 100 packets of overhead produced, for 100 networks 100 into 100, no, it may be 1000 square. Okay, so too many nonlinear increment is there in overhead packet produced if the network is scaled up. So that is what they're saying, that the control overhead, hence the control, due to control overhead, the performance degrades when the same routing protocol is used in a large network. In hybrid wireless networks such as MCN, so multiple cellular network, we have seen that. That was yesterday's first topic. So in hybrid wireless networks such as MCN, one has to provide continuous connectivity to a large number of users in a traditional cellular network. Consequently, the requirements for MCNs are not met by this ad hoc wireless network routing protocol. So scalability is the issue. If in smaller network, ad hoc network, whatever routing protocol we are applying, the same routing protocol may not be suitable when the network is scaled up. Okay, because from 10 to 100, if we are increasing the node number from 10 to 100, maybe the same routing protocol might not work. So scalability is a big issue for designing a higher volume of HWN, that is a hybrid wireless network. So protocol which was used for smaller number of network might be okay for smaller number of ad hoc network, but for higher volume or higher number of sensor node based hybrid wireless network, this kind of routing protocol might not come in use. So we have to design a special kind of new kind of protocol for hybrid wireless network when it is scaled up. Okay, so the network might be carrying some 1000 nodes or something. So new routing protocol has to be designed. Lastly, there is a conclusion that there has to be a special approach for designing of routing protocol for hybrid wireless network. This protocol should be able to effectively utilize the ad hoc radio, and that is ad hoc communication, in the presence of fixed infrastructure or enhanced network capacity. So this is the best understanding or basic understanding of hybrid wireless network. That is, it will use ad hoc communication as well as it will use the good features of base station. So this effectively utilize the ad hoc radio and fixed infrastructure. So fixed infrastructure means the base station. Okay, because in ad hoc network everything is not fixed, everything is mobile, everything is movable, dynamic. Okay, so hybrid network, whenever we are talking about, it is using all the positive features of ad hoc network as well as fixed infrastructure, that is cellular network. So spatial approach in designing of routing protocol is required for hybrid networks. So this question must be asked, that what are the issues in hybrid wireless network routing protocols compared to ad hoc network and cellular network. So these are the 4 points you have to explain, and you have to say that because of these 4 points, direct application of cellular routing protocol or ad hoc network routing protocol is not possible on hybrid wireless network. So this is a question. Next, what we'll see is what is meant by power control scheme in hybrid wireless network. So every network that is ad hoc, cellular, everything, everywhere we are thinking that power must be controlled, because unnecessarily wastage of power is not supported anywhere. So it is saying that power control schemes are important for hybrid wireless network HWN, as they are designed to serve large number of power constant mobile nodes. So same issue, because hybrid wireless network is having the features of ad hoc wireless nodes. So ad hoc wireless nodes are having the feature of power constant. Hence, inside hybrid wireless network also there will be power constrained ad hoc nodes. Okay, and saving their energy, saving their power is a very important job in case of HWN also. So the architecture of HWN utilizes power control in ad hoc mode to maximize the achievable system output. So more is the power saving. In that case, more will be the battery life of the nodes, that is ad hoc node. And if battery life is more, in that case network life will increase. If network life is more, then it will be able to produce more output. So this line is very important. So HWN architecture utilizes power control in ad hoc mode to maximize the achievable system output. So based on the topology of the network formed by the mobile nodes, the base station estimates a minimum necessary power to achieve connectivity. So here, first the base station calculates. So base station is having the whole understanding of the all nodes within its cell. Okay, so if A to B with some intermediate nodes, as we have seen in case of yesterday MCN and HWN and Soprano, that two nodes within a cell is having a base station. So two nodes within a cell is trying to connect to each other. So in that case, the base station will estimate how much is the minimum energy which is required to transmit the power from A to B. So this is a very important thing. Base station on topology of the network from the mobile nodes, they estimate the minimum necessary power to achieve connectivity. Maximum achievable output is a function of the transmission power used. So output will be maximized if the transmission power is minimized. So higher the transmission power, lower the throughput achieved. Throughput means network output. So network output is measured in terms of how many packets, data packets transferred. So more is the transmission power, less will be the battery lifetime, less will be the network lifetime. In that case, network output will reduce. And on the other way, higher the transmission power, lower the throughput achieved. The base station switches to cellular mode if the power used for connectivity in ad hoc mode results in lower throughput than that of cellular mode. So in case of HWN yesterday, we had seen there are two modes. One is cellular mode, one is the ad hoc mode. Okay, in cellular mode, if one node wants to connect to the other node, the connectivity will be established by means of base station. So first node A will send the data packet to base station. Base station will relay it to station B. So in that case, A and B, they are keeping the base station in between. So that is the cellular mode. Every communication, in cellular mode, base station is involved. What is meant by ad hoc mode? In ad hoc mode, if A wants to communicate to station D, then it does not take base station into picture. So A just uses the ad hoc type of communication. So it just sends the data to its node which is beside it. So A, B, C, D was the path, and DCBA was the acknowledgement path. So though base station is there, but node A, B, C, D, they are not communicating with base station unless and until there is a path break. Okay, but then also ABCD is establishing connection between themselves and data communication is happening. So that is a very important thing. So it says that whether the cellular mode will be applied or whether the ad hoc mode will be applied, because both these modes are possible in hybrid wireless network. So which mode is saving more power, that mode will be used in case of hybrid wireless network. So there is always an estimation going on in the base station. So yesterday we have discussed all these things. Okay, not yesterday, in the first lecture of this module 5, that always there is going an estimation of power in base station, that whether cellular mode will be more power saving or ad hoc mode will be more power saving. Whichever mode is more power saving, the switching will occur from one state to the other. So either cellular to ad hoc or ad hoc to cellular in case of HWN. Okay, so this thing is written here. The base station switches to cellular mode if the power used for connectivity in ad hoc mode is lower. Okay, so that switching keeps on happening. So MCN, multi-hub cellular network, this was our topic, first topic yesterday. And there is another power architecture which is called as MUPAC. Okay, so you know the name, multi-power architecture for cellular network. So MCN and MUPAC provides limited flexibility in terms of transmission ranges. Okay, so whenever you are trying to control the power, transmission power, at that time your transmission range becomes limited. So you cannot transmit the data for any longer range. Okay, so that is there. So MCN and MUPAC, they curve down, they reduces the transmission distance, but they helps to save power. Okay, so both the things cannot be achievable simultaneously. I want to transmit as long as possible, then not possible. In that case, more power wastage will happen. Okay, so MCN and MUPAC, they are having smart energy saving algorithms. Okay, so they are curbing down or they are reducing the communication range, but they are less flexible, but they are providing some power related solution. Transmission power is chosen from a limited set of available values in the case of MUPAC. So we can select transmission power. Maybe a transmission power energy is for 5 meter, transmission energy is for 10 meter, transmission energy is for 15 meter. All those things can be set in a node by means of software. So if we set transmission range is for 5 meter, that means it will not be able to communicate with nodes. So one node, if we are setting the transmission range is 5 meter, by software we can set that. Okay. So for any node, if you are setting the transmission range is 5 meter, then whichever nodes are there away from 5 meter, okay, away from the 5 meter circle, they will not be communicated from this node. Okay. So we can have a dynamic communication range for all these nodes. So that control is there in case of MCN. So the transmission power is chosen from a limited set of available values in case of MUPAC. So MUPAC and MCN both are having that transmission power control algorithm inbuilt inside it. So transmission power in for MCN is high, but MUPAC does not restrict the number of usable data channels, but it increases the number of data channels, but does not increase the flexibility, because here the available bandwidth gets divided into different channels, which increases the transmission time. So it's actually explaining how the MUPAC works, not very important. Okay. So also the increase in the number of data channel increases the number of interfaces, which may add to the complexity of the device. Further, at low load, this is not advisable because most of the data channel will remain idle. MCN forces the use of single data channel for all nodes. So there is a difference between MUPAC architecture and MCN architecture. So MCN architecture is kind of a unicast architecture, single sender to single receiver over a single path, data path. Okay, whereas MUPAC architecture is having a multi-path kind of a architecture. So in that case, control overhead will be more. In that case, data waste, energy wastage will be more. In case of MUPAC, the energy wastage as it is more, the output will reduce. Okay, but MCN, it is a single data channel for all mode. So this is kind of a basic introduction of power control schemes in case of hybrid wireless network. Why power control is required, that is explained here, that higher the transmission power, lower the output. That means if you can reduce the power transmission, the overall network output will be increased. So that's why this line is the central line, and this line has to be explained as the basic introduction of power control schemes in hybrid wireless network. Now let us see two different types of power control scheme. These things actually we have done in the module 1. Okay, so this is actually 802.11 architecture, which is a dedicated architecture for ad hoc. So you can see here there are two pairs of communication. So A and B. So A is the transmitter, B is the receiver, or B can be the transmitter, A can be the receiver, and these dashed lines are their communication range. So whenever A is transmitting RTS, this is the circle for RTS, which is transmitted from A, and B is falling within that range. Okay, so it is going to be. And whenever B is transmitting CTS, suppose this smaller dashed circle is the range for B, smaller dash circle, and A is falling within that smaller dash circle. So whatever transmission from B is coming, that will come to A. So A and B will make a pair. Okay, and we can control the power of A. So we can keep the power of transmission range of A as big. Okay, we can keep the transmission range of A as A to C, this distance, very big distance. Okay, and we can control the transmission range of A as AB distance. Okay, so both these things we can do. What happens if you are making the transmission range of A as AC distance? What happens then? In that case, as transmission range of A is AC distance, that means it is bigger than this dashed circle which is shown here. Okay, so in that case, the circle will be from A to C, this radius, and we have to draw a very big circle around A like this. Okay, suppose A is having a bigger transmission range, B is also having a bigger transmission range, then what is the advantage and what is the limitation? Both the things are explained here. Okay, so this is problem you have to understand for power control scheme 1. Control scheme is, if A is having a very big transmission range, then what happens? If A is having a small transmission range, then what happens? So small transmission range diagram is shown here. What happens if A is transmitting to B, RTS, B is receiving it, and B is transmitting CTS to A, A is receiving it, then AB couple will be formed. Okay, AB couple will be formed and AB will be transmitting with each other. Now what happens? C is trying to communicate with D with a very big communication radius, and C will transmit to D the RTS, and that RTS will come directly to A also, because C communication range is big. So whenever C is trying to communicate with D with a bigger power, that will actually interfere with the AB communication, and AB communication will get disrupted. Now you can ask, then why not AB communication was disrupting CD communication? The answer is, AB communication was a low power communication, because when A was trying to talk to B, only B was receiving it. Then B sent the CTS, it was coming to A. They formed a local pair. But C is trying to communicate with a bigger communication range. In that case, CD communication will affect the AB communication. So if you're keeping the power of AB low, in that case, initially they can form a packet. But later on, when other pairs are trying to form a couple, that will interfere with AB communication. So what is the solution? Solution is, A could transmit to B with a bigger communication range. If A is transmitting to B with a bigger communication range like AC, then whatever RTS is sent to B, that will reach to CD as well. So CD will understand that yes, A is trying to establish a contact with B. In that case, when AB contact is established, then CD will not even try to form a couple. So all these things we have seen as hidden terminal problem in case of MAC protocol, that is chapter 1. So this is the power control scheme 1, where the link is established with the smaller power. What is the problem? Then bigger power links will affect this communication channel. So let us see what it is saying. IEEE 802.11 MAC protocol. So we have seen this RTS CTS mechanism to gain the channel access. Here the sender node A, on sensing the channel to be idle. So A first senses that all the channel around it is idle, then it sends the RTS signal to receiver B. Okay, with a lesser communication power only within this circle. The receiver replies with CTS message. Again, CTS message is replied within a small or energy constant signal. Okay. So these messages are heard by the neighbor nodes C and D, who avoid transmission for a pre-specified time interval to avoid collision. Thus, the probability of hidden terminal affecting the transmission is reduced. When variable transmission power is used, so initially A was transmitting with higher power. Now variable transmission power means now the B is very close to A, and A uses very less transmission power, sufficient only for B. So I told you this case that A is transmitting now only for B, and B is transmitting now only for A. A and B, they are forming a couple. So neither RTS nor CTS signal was heard by C and D, because A and B was talking among themselves only. So thus node A is ready to send the data to node B. When the transmission between AB is going on, node C wishes to send data to node D. and finds the channel idle because CD is here. Okay, so CD is idle channel, but since node D is relatively far off C uses a higher transmission power. What happens in that case? This transmission, CD transmission, reaches to B and the collision occurs because A is also sending data to B, and at that time C is sending request to D. Okay, so request from C to D, that is RTS from C, and data from A, both will get collided at position B. So thus start of a new packet transmission C to D interferes with existing AB transmission. So smaller power if you are keeping, AB can produce a couple, but others are not knowing that AB is communicating with a couple. So while whenever this couple kind of things are formed between two nodes, other nodes also should have a knowledge that A and B, they are communicating with each other. But if their A and B is forming this couple with smaller power, then other nodes will not come to know about the AB couple formation because this power is very small. So this is a problem. Okay. So such problem would not have occurred if A and B use the same transmission power as C. That means A transmission radius is big, A to C. Okay, like this. If A had transmitted with bigger power, then C would have known about AB transmission from the beginning only. Then while AB transmission is going on, C would not have tried. So that is what. Such problem would not have occurred if A and B use the same transmission power as C. Hence, RTS CTS of AB would be heard at node C and D both, and hence a collision would be avoided. Collision would be avoided means C will not even try to transmit any data. So this is one power control scheme. Second power control scheme, the same diagram you can check here. The A is transmitting RTS with a bigger power and data with a smaller power. Samely, B is transmitting CTS with bigger power, bigger radius, but acknowledgement with a smaller radius. So this was our last topic in case of MAC protocol. In power control MAC or in case of basic BASIC protocol, we have seen the same thing. That is, RTS and CTS are transmitted with higher power, and data and acknowledgement are transmitted with lower power. So whenever the A is transmitting a RTS with a bigger power, all the node D, C, and everybody is coming to know that A is trying to transmit. Okay, but A wants to just give a feel to everybody else that A is transmitting, but A doesn't want to transmit to C, A doesn't want to transmit to D. Hence, while transmitting, A is transmitting with a smaller power. So telling everybody that I'm transmitting, that thing is happening with a bigger power, that is RTS signal, but actual data transmission is occurring with a smaller power. Same thing happens to B. B is transmitting CTS. CTS is actually meant from B to A. So CTS is transmitting B is transmitting CTS for a bigger radius. Okay, so C and D is also coming to know that A and B, they have formed a couple. So B is acknowledging the data packet. So C and D will also come to know that yes, B is transmitting something, but what is it transmitting? Acknowledgement signal. That is not for C and D, that is for A only. Okay, so in power optimization scheme 2, this is for HW, and this is very smart kind of power control scheme. Okay, the available bandwidth is divided into n channel. Each channel operates at different transmission range, same as mu pack. So this is actually the power control scheme as found in mu pack. In this new scheme, the transmission power RTS or CTS is kept at high, whereas the transmission power for data and acknowledgement is reduced to the sufficient value. So A and B, they are transmitting RTS and CTS just to inform others that we are forming a couple. But once that couple is formed, the actual data transmission is not for everybody. Hence, actual data transmission radius is equal to the distance between A and B. So data and acknowledgement transmission is for smaller power. RTS and CTS transmission is for bigger power. So this solves all kind of hidden terminal and exposed terminal problem. So in the scheme, the transmission power of RTS and CTS is kept at high, whereas the transmission power of data and acknowledgement is reduced. Number of nodes affected by transmission are the same that in the non-power optimized scheme. This is important that these nodes are prevented from transmitting data in order to prevent a collision with the ongoing transmission as per collision avoidance paradigm. So here there will be no collision because A is telling C and D that I am transmitting by RTS signal. B is telling C and D that I'm transmitting CTS, that is I'm in couple with A, and then B is sending the acknowledgement signal with a lower power. So this acknowledgement will come only to A, acknowledgement will not go to C and D. This data will come only to B from A, data will not go to C and D. Okay, so telling others that I'm doing it and doing it only for the coupled node. So this is the characteristic of very smart HWN kind of power optimization scheme. Example, node C and D, here the RTS sent by node A and CTS sent by node B, though they may not hear the actual data and acknowledgement transmission. Thus, node C and D are prevented from transmitting data on the same data channel as node A and B are in couple, and they have formed a couple with RTS CTS. Hence, the chances of collision during the data transmission interval is very less. It reduces. So, this is a very smart kind of power control optimization scheme which is found in case of HWN. Okay. So this is also explained here. The performance of the scheme depends on the estimated distance between the nodes. So the same thing, some features are explained. Alternatively, the sender can translate the signal strength information of the received message from the neighbors and approximate. So these are some features which are explained of this power control optimization scheme 2. Please go through. We'll finish. So there are two more slides. Okay, we'll finish with load balancing. So I told you that load balancing means sharing the overall data load or data traffic among all the paths that are available. If not done, then what happens? That is the problem here. So load balancing refers to the distribution of relay traffic or load uniformly throughout the network so that no region in the network is particularly overloaded. So only one path is overloaded, only one path is used repeatedly. That should not happen. Need for load balancing arises from the fact that amount of traffic relayed by a node in a static multi-hub wireless network depends on position of the nodes in the network and node density in the region. In case of fish eye kind of protocol, routing protocol, we had found that generally toward the center of the whole topology, the node traffic density is too high, or sorry, data traffic density is too high. That means whichever are the nodes which are situated towards the center of the topology, their battery get exhausted very fast. Okay, we will be seeing the diagram. Okay, so in the whole network, the central part of the topology is getting exhausted. So nodes that is there in the central part of the topology are getting exhausted. And once they are getting exhausted, battery getting exhausted, no kind of data communication can take place in those central region. So that's a problem. Okay, so it is saying that the need for load balancing arises from the fact that the amount of traffic relayed by a node in the static multi-hub wireless network depends on the position of the nodes in the network and node density in the region. So if it's a circular kind of area towards the periphery, whatever data nodes are there, at that point periphery traffic density will be very less, and the nodes which are there towards the center, there the data traffic density will be very high. Okay, so as a result, the nodes close to the center of the network need to relay more traffic than the node away from the network. Okay, so there's a very important thing that nodes which are towards the center of the network have to relay more data than the nodes which are away from the center. So the nodes which are there in the center, okay, this will have to carry more amount of data compared to nodes which are there closer to the periphery. So continuously the nodes which are situated at the center, it is said that load density varies with distance from the center of the network. Okay, so just check the volume. Okay, volume of data to be transferred. So as you are coming from right to left, that means as you are going along the diameter, okay, the data traffic density is increasing, and exactly at the center, data traffic density of the nodes is maximum. So this is actually a area in which lot of nodes are deployed within this circular area, and nodes which are there at the center, they're carrying huge amount of data. Okay, so this is center and this is distance from the center. So as we are going away from the center, the amount of data in the carried by the node is reducing. As we are towards the center, amount of data carried by the nodes are too much. So that means what happens is whichever nodes are there toward the center, as they are carrying too much data continuously over and over again, those nodes battery will get exhausted. And after certain time, what we'll find is there will be no alive node toward the center of the network. So a hollow will be created. A ring formation will happen because all this area is carrying the nodes which are failed nodes. Failed node means the battery is exhausted. So from this study, actually this is taken from a paper, from this study it can be found out that if there is a facility that we can go and change the battery of the nodes, we have to change the battery of the nodes which are situated toward the center. Because if we are not doing that, as central nodes are carrying too much of data periodically over and over again, they get exhausted very fast. So this is called as a ring formation. This also can be asked for a 2 or 3 marks question. Then what is meant by ring formation in a network? So it says the ring formation at the center of the network happens because huge node failure due to excessive load. So you can check the diagram here. So here it was a connected network. Okay, as you are going from across the diameter toward the center, nodes are carrying huge load. In the left side away from center, it is carrying less load. Right side away from center, it is carrying less load. But here if you are saying this is a ring kind of formation has happened, that is these are failed nodes. In that case, if you are coming from left to right along the diameter, what you'll find is the data communication is increasing. Suddenly the nodes which are here, they are carrying huge amount of data, then no communication here, because all these nodes, their battery has been exhausted, hence they are not carrying any data. So towards the center there is no data. Okay, so what is the y-axis? Y-axis is load per unit area. Okay, so there is no load at the center because these batteries have got exhausted. These nodes are dead nodes. They have created a ring. They have created a hollow or void at the center. Okay, again if you are going from the right, so again from this point towards right, the data amount of data communication is reduced. So left side, this diagram is load density varies with distance from the center. So it is away from the center, it is low, and the center it is high, again it is low. And too much usage of this kind of pattern will form a ring at the center of the network, and then because of huge node failure at the center of the network, because of excessive usage of those nodes, there will be formed a ring. So as a result, the nodes close to the center of the network need to relay more traffic, and the nodes away from the center. The problem is not very severe in highly mobile ad hoc wireless network. Why not? Because these nodes which have got exhausted, okay, little power remaining, and they will come out, and the nodes which are full of energy, again they will come in. So if node mobility is high, we can exchange the nodes with lower energy node will go out from the center, and higher energy node will come toward the center. So if it's a dynamic kind of a network, we can avoid forming this ring. Okay, but if it's a static kind of network, no mobility allowed for the nodes, in that case this kind of ring formation will happen. So ring formation happens only in case of static node, but if in case of dynamic node, by proper arrangement we can avoid the forming of this ring, or we can avoid big ring formation. Maybe a very small ring formation there at the center, but big ring formation can be avoided. Okay, but it assumes the problem is not very severe in highly mobile ad hoc wireless network, because high energy node can fill in and low energy node can go out. But it assumes significance in static ad hoc wireless network. Static ad hoc wireless network means wherever you have deployed the node, it will stay there. It is not going to move. Okay, wireless mesh network, this is also static type. Wireless sensor network, static type. And hybrid wireless network, all these are static type, where nodes are not highly mobile. So if nodes are mobile, then we can control this ring formation. If nodes are not mobile in all these 4 cases, in that case ring formation will be severe. So relay traffic at network center. So relay traffic at network center is highest and decreases with the increasing distance from the center of the network. It is shown in this diagram. It leads to rapid draining of battery charge for nodes at the center of the network. So this is the reason which I have already explained. Okay, so for any network, we'll be finding towards the center, data traffic is very high, and towards the side, data traffic is low, that is towards the periphery. Hence, it leads to rapid draining of battery charge for nodes at the center of the network. What it does is it forms a ring in which the coverage at the center of the network is poor. So if ring formation occurs means there is no sensor at the center of the area which can absorb, which can receive, or which can transmit any information. So no exchange of information happens here, though this is the most important part of the network. Okay, this is the fish eye of the network. Okay, so it forms a ring in which the coverage at the center of the network is poor. It is called as ring formation problem, as is caused for load balancing scheme in multi-hop wireless sensor network. Position dependent traffic load causes the nodes in a high traffic area to drain their battery charge faster, thus reducing their normal lifespan. So in this case, the question is, have we done load balancing? Answer is, we have not done load balancing. If we had done load balancing, the curve would not be like this bell shaped curve, would have been a straight line. If the curve is a straight line, means all the nodes are equally stressed. Okay, but in this case we are finding that the central nodes are more stressed and side nodes are less stressed. Hence load balancing is not done. Hence, there will be a ring formation at the center of the network, which will cause a void, which will cause an area where no data exchange will take place. So this is the problem of node balancing, which occurs in case of hybrid wireless network. Now, how to solve this load balancing issue, or how to solve that there should not be any ring formation, how to solve this problem, that we will see in load balancing in next day, that is tomorrow. We will see that. So only the problem I have told you today, what is the problem of load balancing, that is, it is the ring formation is the problem. And by load balancing, how can we manage that ring formation will not occur? Okay, so that part we will see tomorrow. So this lecture will be uploaded today.